Hey, 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 what's up, everybody? Welcome to Astronomy Daily Live. Hope everybody's doing well out there today. Hope your past 23-ish hours was good. Mine was normal. Uh, yeah, just the usual, you know, life insanity, which for me is like, yeah, about like that. So yeah, everything's well here. I'm gonna get this off of my Linux machine. Uh, so yeah, I'm a little bit late. It's already 2:02 UTC. I can't believe it. But yeah, I was a little bit late because I was looking at the Hayabusa uh, images and website and everything else. And I think that's sort of what I want to do tonight. If you're game, if you're game for it, Bobby, what do you think? Cheers. So yeah, I've even got a check out this shirt. So there's a shirt, a very colorful shirt. I usually wear pretty plain things, but this is a pretty cool shirt. So yeah. So come on in, everybody. Take a seat around the circle, out on the porch with the lounge chairs. We're just laying back, and the sun here at least is still setting. It's got another, I don't know, 15 or 20 minutes or so before it's before before the Earth eclipses it, blocks our view for a little while. But that's what happens when you live on a sphere. It could happen on other shapes. It could technically, I suppose. I don't know uh, how well those other shapes would match all of our observations, but yeah, it's possible. But a sphere is probably the simplest explanation, and I like the simple explanations if we can get away with them at least. So yeah, Hayabusa is really killing it. Um, I I have been aware of this mission, but I guess I never explored any of the details. Just thought, okay, it's a sample return to an asteroid. That's very cool. That's very cool. But yeah, uh, going into the details a little bit, it's like, wow, this is going to be a pretty interesting uh, mission, and they're I guess they're supposed to arrive tomorrow sometime. They're supposed to arrive, you know, however they've determined what arrival means. But I think they're supposed to arrive either tomorrow or the next day, something like that. And so that's very exciting, right? That's very cool to have an Earthcraft uh, so near uh, an object that, as far as we know, has never been seen by human eyes ever, ever. So yeah, it's a pretty extraordinary thing to be able to see those kinds of things for the first time. I want to be the I want to be the person who actually sees that first. I think that would be very cool. That would be very, very cool. And you know, I mean, after you look at it a while, it's like, okay, you know, it's cool in different ways, but you know, it is. Uh, After you look at it a while, it's like, okay, you know, it's got a particular, you know, it becomes recognizable, right? From that point on, it's like, oh, I know what that is, and so you know, you start remembering what it looks like, and yeah, but it's going to be very exciting, very interesting, and yeah, they just updated their website to something that I consider extremely, extremely clever. Uh, Really, really cool what they just posted on their website a while ago, and I think we're going to go through that as well because I think that's extremely cool. So, you know, uh, since I don't know much about the Hayabusa 2 mission, what I thought that we would do just as a jumping off point, and I mean, it could be a beginning and an end, but not necessarily. We'll see where this goes. Um, we can start at Wikipedia and just sort of see what Wikipedia has to say about uh, about this spacecraft, and maybe we can pick up some interesting little tidbits, um, since it does look like it's near its first phase is almost complete, right? It's almost where it was supposed to go. So we're at the end of one phase and the beginning of the next, and that's always exciting when you have the end of one thing is like critically connected to um, the beginning of something else, and they're actually sort of dependent on one another. One has to go away, and the other has to appear. So yeah, cheers. So yeah, let's take a look at some info on um, Hayabusa, and then we can go over to their website and look at the amazing post that they made earlier today. It's I haven't even looked through it all, but it really is. It's sort of blowing my mind. It's pretty awesome. So I'm going to share the screen. Share that screen, and we're going to go over to Wikipedia. So it's It's an asteroid sample return mission that's operated by JAXA, right? The Japanese Space um, Agency. So it was launched on December 3rd, 2014 at 4:22 UTC, 4 4:22:04 UTC. The target is asteroid 162173 Ryugu. Ryugu. Um, Hayabusa 2 is expected to arrive at the target in July 2018, survey the asteroid for a year and a half, depart in December 2019, and return to the Earth in December 2020. So the spacecraft features ion engines, um, upgraded guidance and navigation technology, antennas, and attitude control systems. Operations at the asteroid will be similar to those of the previous Hayabusa, but with an explosive device to dig the asteroid surface for fresh sample material. So yeah, this is just absolutely insane what they're going to do. So some they've got a they've got some cameras. They have a near infrared and a thermal infrared camera. And then they have LiDAR. And then they've got the sampling device itself, which is some kind of an impactor, and a camera on top of that. Then they have this lander slash rover, and it's actually four uh, lander slash rovers. It's four of them. So this is insane, you know. Um, so let's see. I'm just looking at the cameras here. The optical navigation camera. Um, the near infrared spectrometer. Oh, excuse me. So that's a spectrometer, not an imager. It's just going to be looking at the light that is, in fact, the near infrared light that is coming off of this object. Light detection and ranging. Cool. Thermal infrared. That's cool. Okay, well, hopefully they can do what they want to do with that. So the sampling device is similar to Hayabusa. The spacecraft approaches the surface of the asteroid, and when the sampling horn touches the surface, a projectile is shot at 300 meters per second to the surface of the asteroid, and the resulting ejecta is collected by the sampling horn. The ejecta moves to the sample catcher by its own momentum under microgravity conditions. So to remove the space-weathered uh, surface and collect the fresh sample, Hayabusa2 carries the small carry-on impactor. It's a small drop-off, explosively formed penetrator consisting of 2.25 grams of copper contained in a 4.5 kilogram shaped charge of plasticized HMX. So the impactor will be released while orbiting the asteroid. A second instrument will then be deployed, the deployable camera. This camera will observe the explosion of the impactor and will strike the asteroid with a velocity of 2 kilometers per second. Okay, well, cool. That's very, very cool. And then they've got these landers, rovers, right? So Minerva 2-1 deploys rover 1A and 1B, cylindrical in shape and pretty small, right? 18 centimeters. Let's see. Where's my ruler? I don't know where my ruler went. I don't see my ruler anywhere. It's usually pretty nearby, but I'm not seeing it, which probably means one of the kitties stole it. Hey there, Totterbert. Nice to see you. Been watching a couple of your most recent videos. I definitely have to admit that I do not have passion for radios that you have. I think it's just absolutely awesome. Uh, that you can appreciate those kinds of things. I think it's great. So yeah, you must have quite an amazing collection. Uh, yeah, so pretty impressed. For what it's worth, pretty impressed. Yeah, I cannot find that ruler anywhere. Anyway, it it was or is 18 centimeters in diameter and 7 centimeters in height. So it weighs like 1.1 kilograms. They can hop around. So that just has these both just have wide angle, or they've got a stereo camera, a wide angle camera, and a thermometer, right? Um, so then Minerva 2.2 is a different shape. It's an octagonal prism shape, 15 centimeters in diameter, 16 in height, 1 kilogram. It's got two cameras, a thermometer, and an accelerometer. So it'll be able to measure its motion and how it's moving in that environment. All of our cell phones have accelerometers on them. That's how they know. Uh, at least that's one of the ways they know how to rotate your screen. You know, when you want to go from like portrait to landscape. That's I think one of the ways that it knows that at least something has moved. So yeah. So m- more cameras, a thermometer, and an accelerometer. And then you've got Mascot. And Mascot is a infrared spectrometer, a magnetometer, a radiometer, and a camera. And it can hop. It can hop around. So that's pretty cool. It's going to be pretty interesting. Going to be pretty darn interesting. So they're going all the way in, all the way in. They're landing this thing. Then they're gonna shoot stuff into it. Gee whiz, how violent! So pretty amazing. They've packed a lot into a little mission. Um, yeah, for sure, sure. And I think did I? Yeah, I think over on my Discord server, I think I did grab the full link. So what these people did, and this is the let's go to the actual site here. You can sort of see uh, they provide a little map eventually uh, to show us where the spacecraft is right now. And wow, it's at it looks like it's sitting at 20 kilometers. 20 kilometers away. Velocity is 0. So I think that sort of tells me that maybe it's arrived. It's arrived because that was going to be the home position. So I'm thinking that Hayabusa 2 is in its home position. You can sort of see when you see the purple line here. It's kind of hard to see, but this is the actual path it took. Right, it came in. It did and uh, well, this was on June 22nd. It made a few maneuvers and came in, did a hard stop, scooched over, started up again, and glided right into home. So it's at 20 kilometers and not moving. So that's very cool. I think I can say definitely congratulations on that. It's very awesome. This is a pretty exciting mission. You know, they're actually gonna scoop up some stuff and bring it back to Earth, and they're actually gonna. It sounds like they're going to scoop up some stuff that has sort of been dug up. Right, they're gonna throw this explosive device, and then they're going to grab samples from what came out. So, well, good luck with that. You know, I you might be surprised. I think you probably will be, no matter what. But you guys might be in for an interesting surprise. Don't know. Don't know. Something that we can't even think of. I don't know. Don't know. But the pictures are looking really good, right? The pictures are looking really great. And what I wanted to share was just this post that they did today. So what they did is they at the beginning of June they went around to all the members of the project and any kind of professional artists or anything, and they were asked what they thought Ryugu might look like, and they were asked to, draw it or represent it in some way, right? And so, um, you know, what they say here is absolutely true, right? At that point, right, Ryugu was just a bright spot on their cameras. That's all it was. They couldn't see any kind of detail at all, right? So the exact shape and structure of that asteroid was unknown. I'm just sort of reading here. Uh, as the asteroid had never been seen in detail, we therefore asked everyone to imagine what Ryugu might look like. And so these are what everybody came up with, and they all made like little comments. So I just want to go through a few of these, and maybe make some comments. A lot of these are probably not what it's going to look like, probably not, but I appreciate. So this this uh, member of the team writes, I tried to draw the worst possible pattern so that even when the asteroid is rotated, there's no change in the light intensity. I pray that the actual Ryugu is not like this. Haha. If we assume this imaginary picture is accurate, then nothing can scare us. Haha. Well, now we know that one of the reasons why um, um, Ryugu doesn't really change much in light intensity, at least from, um, yeah, I guess, well, with that, yeah, it's not really tumbling much. It's spinning, but it's not really tumbling much. So it's only spinning on or rotating basically on one axis. So when you look at it from far away, I'm thinking about that. It's like, well, unless there's some pretty serious features on the moon itself, dark patches, light patches, all of that. If the surface is pretty uniform, then we are definitely going to see the same light curve all the time. It's going to be a nice, smooth, you know, uniform light curve. So, yeah, and that's, of course, what we're seeing. So, here's an interesting one. So this was predicted to be what Ryugu uh, looked like before anybody knew what it was going to look like. This team member drew this. So I think he's going to be very surprised. I'm surprised at how accurate that actually is. I mean, let's go to the real thing now and look at the latest image to be posted. I guess if yet, we'll take a look at this too. But I'm hoping that you all are keeping track of this a little bit. Here we go. Okay, so there it is. That's what it actually looks like, right? And this is what this guy drew. So, you know, not too bad. Not too bad. He's got some mountains, he's got some craters. He's got, there's that's interesting shape. I don't know. My guess is that they probably were able to do a little bit of modeling with the light curve, and the model probably popped out this kind of shape, right? But so far, the little 3-frame movies that I've seen, this thing is almost moving exactly right to left, and there seems to be some kind of equatorial band here. Do you see that? Huh. Anyway, let's keep going with these because they're extremely cool. So this one I don't quite get, but um, yeah. So I don't know. They sort of I don't know this what they're saying here. I don't quite understand either. Um, so it's a little strange. We'll just move on, I guess. This one I thought was absolutely hilarious, right? Because they want to be able to land in a good spot, right? So what he's showing here, right, is this huge, just absolutely flat area where they can pretty much just choose wherever they want to land on here. So, but they say we can land on this shape of asteroid very safely, although it has a lot of surprises, right? It has a straw hat shape, vast plain of sandy land abundant in water-rich minerals, enough pebbles to act as landmarks on the flat landscape. So that's what these dark things are. A single spin axis, but below the maximum moment of inertia to avoid breakup. Well, they got 2 out of 3. They got a large spin axis. Well, no, did they get 2 out of 3? No, no, no. Well, they got 1 out of 4. 1 out of 4. That's not too bad though. That's not too bad to predict that. I get 2 out of 3. I don't know how I got that. So that's project manager. That was from the project manager. So here's another one. I think it's just showing like a portion. Um, so yeah, I don't have much to say about that. Sort of showing like a pencil drawing with look. We've got the Big Dipper back here. That's pretty funny. He drew in like little sand dunes or something. That's kind of interesting that he or she would do that. I don't know what this is down here. There's a little DNA strand there. That's getting pretty wishful thinking there. Pretty good though. So yeah, this is some kind of a uh, I don't know if it's some kind of like ice cream treat or some kind of chocolate. Uh, don't know, but that's sort of what they thought it would look like. There's another one. Saw it at the supermarket, and it looked like Ryugu. But yeah, its reflectivity there is way too high. So there's another one. I think this, yeah, this is the same thing. He says that all the black and round things have come to look like Ryugu to me. That's pretty funny. So it says that the estimated asteroid shape is based on hope and wishful observations of the person in charge of the AOCS. I don't know what the AOCS is. Oh, Attitude and Orbit Control Subsystem, uh, which is him. He is responsible for AOCS. Uh, I think it would definitely be definitely fun for operations if it were like this. So yeah, just sort of a weird, clumpy thing. Um, I don't know if these are supposed to be like little rocks or something, all the same size, or if that just sort of shows the orbit. Probably just shows the orbit. Yeah. So it says, this is an extremely difficult to approach. I have to avoid hitting two small satellites around a perforated contact binary. So, what is the safe orbit that will pass through the hole? Oh, yeah, this is like assuming the worst case. That's what the asteroid is going to look like. It's like, you know, how do you land on that? So I think that's pretty funny. There's sort of the same thing. There's a rotating baseball, a two-seam fastball with a spin so fast, too fast to touch down. So that's something that they have to worry about, right? They have to make sure that they're not going to be flung off. So yeah, they probably have a pretty good measure of that velocity by now with those three image sequences. Uh, they can get a pretty accurate idea about how fast that thing's moving. See if they can land at all. Haven't heard anything about that. So here's another one. Oh yeah, it's the same one. Um, so another rubble pile celestial body. Uh, so yeah, he or she is thinking that it's some large object with cracks and valleys and whatnot, and then this huge amount of debris just sort of in the area. So yeah, interesting. So this is a mysterious class of asteroid regolith that floats in an electric field at the daylight boundary. Because the grains are charged by the photoelectric effect, it sticks to the spacecraft that the plasma from the ion engine is not released. So yeah, that's pretty hazardous. Pretty hazardous. So here's a representation from a little less experienced mind. Black and dark. Rice grains. And wheat chocolate. Okay. Yeah, so, it's a good interpretation, I guess. This one I thought was pretty interesting too. But that's, I don't think that that's too imaginative, though, right? I mean, you got the big holes, some cracks, some craters. It's bumpy. Eh. So yeah, I don't really think. Let's see what he says here. Huge holes from craters. Number of craters is not saturated. Large and small craters can be seen globally. Large and small can be seen globally. Ooh, dude, I'm not seeing craters. I'm not seeing craters. I mean, this is probably some kind of crater, right? Crater, crater. I mean, look at that. There's like a line of craters. But I'm not seeing a lot of craters. At least not a lot of new ones. If you want to, you know, assume that a new one would have a nice sharp edge and a nice an, well defined walls. Who knows, right? Who knows what's going on here? But so that's not too bad. Um, Inside of the craters have slightly different colors and spectra to the surface layer. Well, we're not going to know that from that image because that's just a single wavelength, and we need multiple wavelengths to see colors. There are boulders in large and small sizes on sizes all over the surface. Absolutely, absolutely. That's sure thing. Big boulders, small boulders. Yep, we're covered there. There are plains with few boulders and craters with a lot of gravel. Nope. Maybe a plain, if you want to call that a plain, hard to tell. Traces of cracks. Traces of cracks. Not at this resolution. Maybe you see this thing here and maybe here. I don't know. Look at there's some funny scratch marks. Yeah, that's kind of interesting, isn't it? These parallel grooves here. Do you see them? And here? Interesting. I think this is going to be very exciting when we get close. Floating dust. He thinks there's going to be floating dust too. Well, that's to be determined, right? They got to overexpose the asteroid probably to be able to see any dust, or they got to be backlit. See if they can get the asteroid between them and the sun, um, and have the asteroid block the sun out, right? Occult the sun, and then take a nice long exposure, see if there's any dust. So, you know, not too bad. He wants it to be, or he or she wants it to be convenient for operations. So, it's not going to be that easy. This person thinks it's going to be cake type. So, I think I think we can rule that one out. Although, wow, there's just some really bizarre stuff here. Yeah, I'm interested in seeing some more high res. So, yeah, I think they missed on that one. They sort of missed on that one. This one's pretty complicated. It's a porous asteroid with several fractures, easy to break, sandy beaches, couple of craters and rocks. Finally, an unexpected flat and smooth region to present a puzzle is present to puzzle scientists on its formation. Surely, Ryugu sample will not taste like sugar candy, but delightful discoveries are going to be revealed. Yeah, well, I don't think there's any flat regions. So this person thinks that it's going to look like uh, it's um, a turtle carrying a treasure box on its back. The treasure box contained the old age of Urashima. Okay. It would be interesting if the asteroid had a satellite. So I tried a treasure chest type moon. Cool. Yeah, I don't think they've seen any satellites yet. I think they would have by now. So, okay. It's annotated in Japanese, so I'm not going to be able to help with that. He did this on May 30th. So, yeah, I don't know what all that says. Craters, mountains, boulders, I don't know. Maybe the rotational axis here with the equator here and a ring around it, a little splooge out. Now that's pretty amazing. What do you think of that compared to what we're seeing? That's not too bad. They're still thinking craters though, right? And I think there are some. There are definitely some on the other side of this, but nothing like that. But pretty interesting that they've also done a sort of a sharp edged one, and this was drawn, they say, 30 years ago. So that's pretty interesting. There are satellites and dust, then the trajectory analysis seems like it would be fun. It is difficult to operate the spacecraft, but so yeah, they're thinking dust. This is dust and mountains and seas and cracks. You can definitely tell what this all is. Mountains, maybe big mountains. I don't know. Big, big chunk gone. Big chunk of it gone. This is rotational axis, maybe. So, like the nucleus of comet CG, there are intense irregularities. Looks like holes left after ice has evaporated. It may be a bit painful to find a safe place to land. The surface is covered with black carbonaceous minerals. In some places, there are also lightly colored minerals. Well, I pointed out that this top part up here has a really, seems to be like a pretty flat, very shiny spot. I'm surprised they wouldn't see that in the photometry. I don't quite understand this one, but there it is. So this is just a purple potato. Now, I have a purple potato story. It's very, very short. Um, when I first saw a purple potato, I was very turned off. I was like, there is no way that I can eat something purple. There's just no way I can do that. But it's like, oh, let's try it, let's try it, let's try it, let's try it. So finally, it was probably a year, right? It was probably a year. And it's like, okay, all right, I'm not gonna like it. Already decided that I'm just not gonna like it, right? Not gonna like it at all. So I don't know how we prepared them. Probably pretty simple. We probably, just steamed them, um, maybe steam them and then bake them. Not exactly sure. Um, might have fried them first. I don't remember. Don't remember. Probably steamed and maybe baked. Um, but I can tell you that purple potatoes are probably the most tastiest potato you will ever encounter. They are very awesome. The only real problem with purple potatoes is that they are very starchy, more starchy than sort of the regular, russet potatoes, that you get in the bags. Um, they are much more starchy than that. So not very good for uh, well, maybe good for mashed potatoes. I guess it's sort of uh, how you like your consistency. If you like a nice goo, then mashed potatoes for sure. But these things just steamed and or like baked or fried, like hash browns or something. Very awesome, very awesome. So anyway, that's what they think it's going to look like, and well, no, not really. Let's see what else they have here. Now this one's pretty amazing. They've looks like they have a lot of things right. So again, I can't read Japanese, so I don't know what the details are here. But they sort of got the grayscale right, and they're thinking a few craters, right? A few craters, and yeah, as I said, I think on the other side, we can actually look. We can look at the little movies, and I think of this before. You can see practically the whole thing. So here's a here's a pretty big crater, right? And it looks like there are two of them. Let's enlarge this, right? Because there's a crater here and a crater here. So that's this one. So this one here is this, right? But there's a crater here. These look like mountains. This looks almost exactly like the other one. Don't you think? Um, let's see. Let's pull up the other one now. Ryugu. Ryugu. Yeah, I guess kind of hard to tell. There's these three here. Yeah, maybe. The big crater and then these three. No, yeah, big crater, these three. Maybe. Anyway, not a lot of craters, but something really unusual is going on up here. I mean, something really bright. Yeah, it's this. That is pretty bright, isn't it? That's a lot brighter than the rest of it. So I don't know what's going on there. Yeah, I don't know. I think it'll look this. I don't know if this is. No, there. Yeah, no, I don't know if that's the same crater or not. I don't think it is. There's those three. Could be. You see the big crater here, and then one, two, three, and then maybe like one in the middle. I think that's what I'm seeing here. Big crater. Oh, no, it doesn't really work. Yeah, well, it's hard to do this kind of stuff. But wow, there's something really interesting up there. Anyway, let's keep moving on this. So pretty good, pretty good. That's not too bad either, right? Not a lot of craters, not a lot of craters. Maybe one big one, lots of rocks. Looks like maybe debris. So the North Pole and the South Pole are brown, and the equator is light brown or yellow in color. In addition, it seems like there's a light blue part within a wilderness of boulders. Uh, Lots of water, he says. He or she says. Hmm. So is this the same? No, this is a different person. Almost made exactly the same looking thing. Now that's not too bad. That's not bad. Like a slightly flattened sphere. Okay, they got that wrong, but rocks from a few meters to a few tens of meters are widely scattered and shallow. Relaxed craters can be seen on a number of places. There also seems to be different surface environments, such as linear features and relatively smooth places with few rocks. At mid latitudes, there are places with fewer rocks that seem easy to land, but it also seems interesting to land in a crater. So yeah, I don't know. So there are copious large craters and hydrogenated minerals. When you look closely, you can see that among the relatively smooth terrain are scattered rocks that are several meters in size, making this a rough surface environment. Landing may be quite difficult. So the asteroid has a cuboid shape that is reminiscent of the treasure box. Now, isn't that interesting? Because it does. It does have sort of a cuboid type of a thing. I'm seeing, you know, angle, 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 maybe some kind of line here as well. So, yeah, I mean, maybe a line here. So, I'm thinking that this has got an interesting geometrical shape for sure. Yeah, see, they they did have some pretty good light curve observations from the ground, um, which said that it has a relatively well ordered structure. Well, that it does. Um, so, contrary to its appearance, the asteroid has an uneven gravitational pull, um, which is enough to make an engineer cry. Rumor has it that by the time Hayabusa finishes the mission and returns to Earth, the project members will become old because of fatigue. That's pretty funny. Peach-type asteroid. Asteroids have collided and stuck together. This person's responsible for the ion engines. So just a peach type asteroid. A heart type is quite good, but I do not want to destroy the heart with the impactor. So yeah, the impactor could blow this thing up. Which could be interesting, you know. I mean, wouldn't that be cool? Wouldn't that be an interesting use of these nuclear bombs? You blow up asteroids. Is it ever going to come to that? I don't know. Don't want to put any thoughts in anybody's heads, but could be pretty interesting. Everything in one huge bowl, including debris. Now, see, I mean, this person isn't really showing a lot of craters either. So they know, right? They know the light curve. Everybody on this project, I'm sure, has seen a light curve. Here we go. This is a Ryugu impossible for touchdown. These navigators are really very, very worried about not being able to land. I think, now look, I don't know much about anything, but I think that there are, just looking at this image alone, right? I think that there's some great candidates, right? So this is supposed to be 900 meters across. So there's 450, there's 225. So this from edge to edge here is about 200, 300 meters, right? Which is about the size of yeah, how long is a soccer field, is a football field, European football field? How many meters is that? Is that 100 meters? Or is that like 300? No, it's got to be like 100 meters, 150 meters. Help me out here, chat. Help me out, chat. Help, chat. All right, we're going to move on. I'm going to keep my eye on the chat, but I'm going to move on. B is a reserve and remains in brand new condition. Thanks to the experience with Hayabusa, we're able to complete the outboard journey without using the reserve. So, okay, that's not really a picture of that's not really a picture of what he thinks it's going to look like. So here you go. Big divots, a few craters, a few rocks, boulders, spin axis. Where should we collect a sample? That would be a pretty easy choice. I don't know what all these are, but these, it looks like a bunch of rocks. I don't know what that thing in the middle is. Big crater, small crater, mountains, kind of lumpy. There's large flat land. Oh, okay. So this is a flat area in the shape of an R. Well, good. That's extremely convenient. Um, at first glance, the surface appears the same everywhere, but you see more variety when you look inside the craters. Okay, thank you, Uncle Bill. I knew that you would be there. Uh, so yeah, 100 meters. So this is like 2 or 3 football fields wide, right? So now you can sort of place yourself, right? You're going to be a pretty small looking thing here, pretty small. So yeah, I see. I as I said, I'm no expert, and we probably don't have quite enough detail yet. Really anxious to see the next image because it'll be from the 20-kilometer point. And this this image was taken at 40 kilometers, so it's half the distance, which means that we're going to be getting quite a bit higher resolution, and it'll be spectacular looking then, and we'll be able to see what all these funny looking markings are all over the place. These weird parallel lines. Look at all of them up here. All these weird parallel lines. I don't know. It's just at the resolution of the camera, so you really don't know. Anyway, let's keep moving here. As the appearance finally becomes clear, I think this will be the shape. I hope it'll look kind of familiar, and I'm praying it'll be easy. Yeah. Well, mm, no, I mean, there's a flat edge here, and there's definitely some flatness going on here. Okay, so it's not called a football field; it's called a soccer pitch. All right. I don't think I've ever heard that term. That's cool. Yeah. Okay. All right. So yeah, I would say maybe 3 soccer pitches uh, across that. So that's not really all that big, right? That's what do I want to say? How many acres? Man, I'm really okay. Let's let's do this. Let's say it's 300 meters. Okay, 300 meters. I pulled out the calculator that is still working. So 300 meters across. Right now, in order to do this in acres, I'm going to have to get it into square feet. Sorry. So 300 meters. Um, that's 30,000 centimeters, which is 11,811 inches. So that's diameter. Let's divide that by 2. So that's 5,905 inch radius. So the area, if we assume that that's a circle, which roughly, we're just getting an idea here. Um, so that's the radius squared times pi. So we're going to square the radius, and then we're going to multiply by pi. And we get that many square inches. We want square feet. So we got to divide by 12 and divide by 12. So that's 856 square feet. Now there's about 43,560 square feet in an acre. 43,560, divide that into that, and we get 17, so 17 and a half acres. Okay, that's 17 and a half acres. That's so half of this is the amount of acreage I own. I own about 10 acres. So a little more than half of this is 10 acres. So cool. That's that. So, 20 acres, 20 acres or so. Okay. Well, that puts it in perspective really, really well. So 20 acres. Yeah. Yeah. Pretty cool. So yeah, they'll be able to do at least twice the resolution, right? Because they're going to be halfway in, and I think that's an inverse squared. So yeah, it should actually be like four times the resolution. So that'll be very cool. All right, let's keep going. Wow, we're already over time. I can't believe it. So that's part of Hyperion. Wow, I didn't know that Hyperion was that crazy. We'll have trouble if Ryugu is a similar celestial body. Yeah, for sure. All of these all of these things have this blue thing in it. Not all of them, but I've seen blue quite a bit. At the uneven appearance, the places where we can land may be limited, as Ryugu is also probably covered in boulders. Yeah, well, it is covered. It is covered in boulders, but I think there's some good spots here. I don't know. We're gonna have to wait and see. So it's we'll see. So yeah, I just thought that was very, very cool, and so hope you enjoyed that. That's you know this kind of stuff we've never ever seen ever, and to be able to be here pretty much in real time, not exactly, but seeing this asteroid emerge from nowhere, yeah, is just, it's very exciting, very, very exciting. All right, well, I think that I am going to get out of here because I am just worn out from all this excitement. Hayabusa, yes, sending back some awesome um, images, and I always hope that we're very surprised. Always hope that, because that's what makes it interesting and exciting and perplexing, and definitely definitely gets me up in the morning for sure. All right, I'm going to get out of here for now. So take care, everybody. Have a great evening, a great day. Hold on to your hats. This Earth is spinning. You are rotating right now at pretty close to 1,000 kilometers an hour, right? Just sitting here doing nothing at all. We are spinning in an insane way, right? So hold on to your hats. It's a pretty smooth ride most of the time. So take care. Um, hit that hit the thumbs up. Hit the thumbs up. Make sure to share this around. We're trying to draw a pretty big crowd. Astronomy is very, very awesome, right? And what Astronomy Daily Live is all about is sharing the passion, sharing, sharing around, showing off how awesome the universe is and how awesome all of us are, right? So, all right, take care, everybody. I will see you on the spin. Take care. Bye.